Day 2 of section 4.6 is on inverses of functions. First I think what we need to do is talk about a few definitions. So we saw inverses in the previous problem set for 4.6, but I want to give you a formal definition now. So if a function f has domain A and range B, then its inverse function, if it exists, is the function f inverse, so f of -1. That's what that notation means. With domain B and range A, defined by f inverse of y is equal to f, if and only if f of x is equal to y, for any y in B. So let's try to figure out what this means, because without much explanation, I feel like this might be a little bit nonsense. So I'm going to draw A and B here. Okay. So here's A, and here's B. So the green is A, the blue is B. So here's an example of a function f. So let's say, I'm going to write this in red. Let's say that f sends this star in A to the triangle. It sends the heart in A to the line in B, and the square in A to the circle in B. And this was f. So the inverse function, all it's going to do is flip the arrows. So let me draw this really quick. So this is going to be f inverse, and the arrows are going to be flipped. So instead of sending star to triangle, we're going to send triangle to star. And instead of sending heart to the line, we're going to send the line to the heart. And instead of sending the square to the circle, we're going to send the circle to the square. So I guess the one thing that's super important is that for f, A was the domain, and B was the range. But for f inverse, A was the range, or the set of possible outputs, and B was the set of inputs, so the domain. So one thing we need to note here is that f inverse flips the domain and range of f. That is to say that the domain of f inverse is the range of f. So I realize this still might be a little bit confusing. I really like to think of these things in terms of arrows, but I know that that isn't for everyone. So I want to talk about how to algebraically check or compute or say, like, let's say I give you a function f of x. How do I get f inverse of x? So I guess what I want to say is how to algebraically find the inverse So I'm going to go through step by step. Say we have a function f. So first of all, I'm going to write f in equation form. So what I mean by that is something like y equals f of x. Now, what I'm going to do is switch x and y. When I do that, I get that x is equal to f of y. And then I'm going to solve for y in x equals f of y. The result that we'll get is y equals f inverse of x. So this is our step-by-step business here, but also we have a really important fact about inverses. When I compose them, so when I compose f of x and f inverse of x, what happens is I just get x. So let's write that out. F of f inverse of x ends up being the same exact thing as f inverse of f of x, and that is x. So this fact is really useful for checking your work. Okay, and I think at this point, what we can do is we can go on to problem 7. That's not problem 7, that's problem 1. What in the world is going on in my brain? Okay, so on to problem 1. Does the function which sends a person to their favorite color have an inverse? This is just a yes or no question. So let's do an example. This example is going to involve me, Gogo, and Momo. So this column will be person, and then over here we'll have color. Favorite color. So what's some colors? Maybe red, yellow, blue, purple, etc. Okay, so I asked Gogo and Momo what their favorite colors are, and I found out the following. Gogo's favorite color is yellow. So I'm going to send Gogo to yellow. Momo's favorite color is blue. And I asked myself and found out that my favorite color is yellow. Okay, so this is totally fine. So this is the function that sends a person to their favorite color, or an example of such a function. So what I want to do is try to make an inverse for this. So on the left column, we're going to have favorite color. So red, yellow, blue, purple, etc. And then in the other column, we're going to have person. So Alicia, Gogo, Momo. Okay, so let's do Momo first. So Momo's favorite color was blue. The inverse should send someone's favorite color to the person, right? So we'll send blue to Momo. Gogo's favorite color was yellow, so we'll send yellow to Gogo. And yellow is also Alicia's favorite color, so we'll send yellow to Alicia. So at this point, this might be too far in the past to remember, but there's something wrong with this. So yellow has two outputs. So the input, yellow, has two different outputs. Alicia and Gogo. So remember that a function is such that each input has exactly one output. So when I try to invert this, when I try to find the inverse, I get something that is not a function. So this function that sends a person to their favorite color does not have an inverse. It doesn't have an inverse. Because it's not a function when I try to invert it.